All right, our next shape is a kite. So let's start in our notes packet. I want to label this shape and then switch over to the family tree, and then we'll kind of actually use both of them. All right, so let's name this kite A, B, C, D. So the main property of a kite, or I would say the main definition, is it has two pairs of consecutive congruent sides. All right, so we've got the sides right next to each other are consecutive. So AB and BC are equal to each other. Same thing with CD and AD. Okay, so that will be sort of like the definition or property number one. We have a property about angles. We have several properties about angles, but the first one is that you only have one set of opposite congruent angles. And this kite gives you a pretty good visual of which set is not congruent. So see how D is much smaller than B. So the set of congruent angles on this kite are A and C. Okay, so go ahead and mark that. Let me add one more property, and then I'll go back and talk about how you can find which set are congruent. Let's add some diagonals here. So let me switch colors. So connect A to C and D to B. And you might be able to visually see this property. These diagonals are perpendicular, okay? So if you see on a kite, you have a shorter diagonal and a longer diagonal. So the shorter diagonal, at the ends of the shorter diagonal are the congruent angles. All of angle C is congruent to all of angle A. Now, those are the main properties we're going to write on our kite. So actually, let's switch over to the quadrilateral family tree and add those, and then come back here. Okay, let's go back up to kite, and characteristic number one is that there are two pairs of consecutive congruent sides. Two pairs of consecutive, I use the congruent symbol, congruent sides. Okay, so the two sets right next to each other, there's only two sets that are equal. Next one about diagonals. The diagonals are perpendicular. Diagonals are, and then let's use the perpendicular symbol. And then I'm going to write one pair of opposite congruent angles. One pair of opposite congruent angles. Now, I don't describe which pair because it can get to be a lengthy characteristic. But there are a lot of properties of kites. If we go back to the notes, I'm going to talk about a few more properties here that I'm not going to write on the quadrilateral tree because I want you to see here. Do you see how I have a right triangle? Okay, so I have four right triangles here. So most of the calculations for kites can be calculated using triangles. I also want you to see this. Look at triangle ABC. Do you see how it's isosceles? Okay, so if it's isosceles, if two sides are equal, then my base angles here are equal. Okay, so then there's just, like I said, there's a lot of properties we can use, and we will see that. Let me add a couple more things here in case you want to use this in your calculations. All right, let me get a new color. Let's do maybe this orange one. So on my diagonals, one of them is cutting the other one in half. So I'm going to put 3 marks here because I've already used 1 and 2. So the shorter diagonal gets chopped in half by the longer diagonal. The longer diagonal does not, okay? And then another property is, actually, I'm going to add another letter here, A, B, C, D. Let's call this E. So I'm going to say that AE is congruent to CE. Okay, so that's going to be an extra property I'm not going to write on the quadrilateral family tree. And then we have some angles. Let's try this purple one. No, I already used purple. Let's do this sort of green one. So angles D and B are getting cut in half. So let's go like this. Let's put an arc there and Let's put 2 arcs and 2 arcs. And then I'm going to do 3. Okay, so I've got that angle ADE is congruent to angle CDE. And then I also have angle ABE is congruent to angle CBE. Okay, so that's another property that we can usually bypass on just trying to remember because we can get there with triangles. So you are welcome to use those extra properties as you solve. I'll probably go back to what you know about triangles because you're not going to remember every single property, most likely. Now maybe you will, and if you do, that's fine. You can use those going forward. But I'm probably going to fall back on what we know about triangles. Okay, if you want to pause the video and try these on your own, go right ahead. I'm just going to keep explaining through the last few examples. All right, in the diagram, PQRS is a kite. So I'd like to just go like this for my benefit. Just mark the basic definition. Find the measure of angle Q. So I'm going to put a dot right here. Okay, now when I look at this, I see 83 and 41 clearly are not congruent to each other. So remember, there are, let me go back to the family tree. In a kite, one pair of opposite angles are equal to each other. So I can clearly see that 83 and 41 are not equal. But so I know that angle Q and angle S, though, should be congruent. Now, the other thing I need to consider on angles, I don't know anything else really about angles in kites, but I do know something about angles in a quadrilateral. So what do all 4 angles add up to? Well, they add up to 360. So what I can do here, I'm going to say all angles add to 360. So I can write an equation if I want to. I could say, I'll call the ones I don't know x. X plus 83 plus 41 equals 360. So you can solve this equation, or you could just take your calculator. You could take 360, take away 83, take away 41, and then take this answer and just cut it in half, divide by 2. Okay, well, either way you want to do it is fine. 2x, I've got 83 plus 41 is 124. If I take that away from 360, I get 236. And then divide by 2 gives me 118. So the measure of angle Q is 118 degrees. All right, so don't forget about that property on the 4-sided shapes. Okay, let's go on to number 4. In kite PQRS, the measure of angle PQR is 78. PQR. So PQR, I'm going to put that on the outside since it's all of Q. TRS is 59. TRS. I'm going to go like this. I'm going to put a little line since I can't fit that in there. Okay, let's find these other measures. QRT. QRT is right here. Okay, so when I'm looking for my equal angles, oops, that's not what I wanted. I wanted to stay here. Let me go back here to the top. So see how these two sides are equal to each other? All right, the two equal sides, in between those two equal sides contains an angle. Those are not the angles that are equal to each other, it's the other ones. All right, so at the end of my equal sides may have the angles that are the same. So I know that all of R is congruent to all of P. So that means these are not 59 each. But what I do know is that, let's see. I do see, let me draw all over this and probably erase it. I do know that this is an isosceles triangle. And what that means is angle R and angle P over here are equal to each other because they're base angles. So if I know that this one here is 78 and these two are the same, I can figure these two out. Okay, so I'm going to take these colors off of here. So I can take 180 take away 78. So 180 take away 78 is 102. And then I'm going to take 102 and cut that in half. So the measure of QRT is 51 degrees. So I'm going to go like this, 51 degrees. And I'm going to go ahead and put it over here because that might be helpful for a future problem. Okay, QPS. QPS. So that's all of angle P right here. Okay, well, I could do something similar with the other isosceles triangle right here. So if this one is 59 at the top, then I know this one is also 59 degrees. So I need QPS. So now I can just add these two numbers together. So 51 plus 59 is 110. 51 plus 59. Okay, and then finally, a measure of PRS. Let me get another color going. PRS. P down here over to, or not PRS, PSR. PSR. So that is this big angle here. Okay, I could do a number of things. I have a four-sided shape. 78 plus these two, all of that coming out of 360. Okay, or I got a triangle over here. 59, 59, what's left over out of 180? Okay, so I might do that one. So I might do 180, take away 59, take away 59. So 180 minus 59 is 62 degrees. Okay, so like I said, you can just turn everything into triangles. And that would be probably the easiest way to do these kites. That way you're not trying to remember all these extra properties that are brand new.